28. Describe in words all transformations to obtain the following function. So the first thing I'm going to do is go ahead and change this to fireproof form. I'm going to add that 7 and I'm going to divide by that negative 1/3. We have y plus 7 over negative 1/3 cosine. And with this 3x, remember I need this to be an x, so I'm going to multiply by 1/3 over 1/3. That way in the numerator, I have x, and then I've got my 1/3. So first thing it says, it's a plus 7. That means I'm going down 7. There is no phase shift because there's nothing with an x. I have a 1/3 underneath the y. That means it is a vertical shrink by 1/3. I have this negative out in front. That means it's a reflection across the x-axis. And then finally, this 1/3 means I have a horizontal shrink by 1/3 as well. All right, moving on to the inverse tangent functions. What I'm going to do is I'm thinking about, I just want to graph. Essentially what we're doing is graphing the top half of that unit circle with respect to the cosine. In other words, this point right here, my cosine is 1 and the corresponding rotation is 0. At the top of the unit circle, my cosine is 0. Its corresponding rotation is pi over 2. This point here, my cosine is negative 1 and its corresponding rotation is pi. Let's go ahead and set this up then. I'm graphing the point 1, 0. I'm just making every box a half of a unit. I'm graphing the point 0, pi over 2. And I'm graphing the point negative 1, pi. And my graph looks like the following. My domain values are in between negative 1 and 1. My range is between 0 and pi. And this one doesn't have any symmetry. It doesn't have line symmetry or point symmetry, so this one is neither. I'm going to go do the same thing for my sine. This time I'm graphing this half of my unit circle. This point right here, my sine is negative 1 with a rotation of not 0, but negative pi over 2. This point right here, my sine is 0 with a rotation of 0. This point up here, my sine is 1 with a rotation of pi over 2. To start, I have the point negative 1, negative pi over 2. We've got the point 0, 0, and we have the point 1, pi over 2. My domain is a negative 1 to 1. My range is negative pi over 2 to pi over 2. In this case, it has point symmetry, which means this is odd. Finally, the tangent, same idea. I'm graphing these points over here. My issue is this point right here for the tangent would be undefined, and that is negative pi over 2. Same thing with here. This would be undefined, and this is positive pi over 2. So on my graph, I don't have any points I can plot, but I do have those asymptotes. So let's go ahead and sketch those in. So negative pi over 2, pi over 2. If I go to this point right here, my tangent is 0, and I've got a rotation of 0, but that's certainly not enough. I'm going to go think about my tangent right in here is 1, and that's a rotation of pi over 4. My tangent here is negative 1, and that is a rotation of negative pi over 4. So I'm going to go out 1, up pi over 4. I'm going left 1, down pi over 4, and we're good. Our domain is all real, so negative infinity to infinity. Our range is negative pi over 2 to pi over 2. And this one again has point symmetry, so it is odd. And remember, you're going to have one of those graphs on your test as well. Moving on to number 32. it talks about we have an angle of depression. That means I'm looking out and down. This angle is 42 degrees. It says the worm is 37 feet from the base. That means technically this distance here is 37. With respect to my triangle, though, this is 37. I want to know how tall is the building. We're using SOHCAHTOA. Opposite over adjacent would be tangent. Tangent of 42 equals x over 37. When you solve that, you end up with x is equal to 33.3. Moving on to number 3, we have Captain Bill goes at a bearing of 70 degrees. So let's draw that in. So again, we're starting with respect to north, going 70 degrees. That would be in here. And that is 12 miles. Then they go at a bearing of 160. Well, this would be 180. So shy of that would be 160, which lets me know that angle in there is 20. And this is 7 miles. And I want to find the distance from where I started to that ending point. Right now, we don't have enough skills to solve it unless it's a right triangle. It does end up being a right angle right here. We figured out this is 20. These would be alternate interior. That would be a 70-degree angle. So this angle right here is a right angle. I'm going to go and use Pythagorean's theorem. So my distance is equal to the square root of 12 squared plus 7 squared. When I type that in, I get 13.9 miles. Second thing, I want to know this total angle in here for my bearing. Well, I know that's 70. What I don't know right now is this angle. Notice you have opposite over adjacent. I'm going to label this angle to be y. So angle y would be equal to inverse tan of 7 divided by 12, which is equal to 30.25. But that's this angle in here. I eventually have to add on this 70, and I end up with 100.25 degrees. I'm going to skip number 34 for just a minute since it's the graphing calculator. Let's go to number 35. This is one of the simple harmonic motion problems. That means it's either d equals a sine of bt or d equals a cosine bt. So we've got our distance. We are told it is, we're pulling it down 10 centimeters, and that's where it starts. So that would imply, first of all, it's a negative 10 from equilibrium, and it implies it's cosine since we're not starting right at that equilibrium point. Finally, I have to go and find that b value there. We've got a period is 3 seconds, so 3 equals 2 pi a. When I solve this, I get 3 over 2 pi. Plugging that back in, remember we take the reciprocal, 2 pi over 3 times t. 36. They want to know what is the horizontal distance between the nearest tower and the aircraft, and then how far apart are the two towers. Here is the first tower. They want to know the distance from here to the base of where that plane would be. So if I focus in on this triangle, I have the degree measure here. One thing I need to be careful, this total distance was 400. This is 10, so this distance in my triangle is 390. We have opposite over adjacent, that's tangent. So tangent of 5.25 is equal to 390 over x. Let's go ahead and plug that in. We get 4,244.33. They want to know how far apart are the towers. So ultimately, we're looking for this distance here. Well, I know this distance. I'm I'm going to use the larger triangle to find this distance in here, which for now I'm going to label to be y. This angle is 4.17. Again, we've got 390 over y. That total distance is 5,349.13. That total distance is the 5,000, and this is the 4,000. Finally, we're going to subtract those two numbers to figure out the distance between the two towers. We end up with 1,104.8. And it actually says nearest thousandth meter, so that would be 1,104 meters. That leaves the last problem, which is the Ferris wheel. You can deal with it algebraically, or we can go ahead and graph it. I'm going to go ahead and plug it into my graphing calculator. Okay, on 34, first of all, here's my equation. Just make sure I did pi times x divided by 8. The second thing I did is I went ahead and changed my window. I changed it from 0 to 70 seconds, and I changed it from 0 to 145 because I knew my maximum height was 142. Let's go answer a few questions. How long does it take her to do 2 revolutions? So if here's where she's at, that would be 1 time around, that would be a 2nd time around. So I could go and find really the time between here and here. If you go into calc, we can go find those maximum points. I use that second calc, I found each one of those points. This was 3 comma something, actually this is 4 comma something, this was 40. So when I subtract the two, we end up with 32 seconds. Now let me go and show you mathematically how can I do that. In here, if I multiply this by 8 over pi, then I end up with 1 minus 4. I think I lost my, it would be a t minus 4 over 8 over pi. So if I take 8 over pi, I multiply it by my normal period, which is 2 pi, but we're going 2 times around. Notice the pi's cancel, you're left with 32 seconds. What is the radius of the Ferris wheel? So that radius is actually sitting right here. This is your midline, which is 72. There's the radius, you end up with 70. Now somebody else said I took my max minus my min. You can see the max was 142, your minimum was 2, you got 140, and again divided by 2, and you get 10. How high is she when she's at 0 seconds? If you have that equation entered, we can go into that table, and let's go change the table set to 0. I'm changing it so I'm on ask. Going into that table, I can type in a time of 0, which is my 2 feet. I can type in a time of 4, and I end up with 72 feet. So again, this one was 2, this one was 72. D, we're not going to have anything like that, so let's not stress over that. Finally, give a time when she reaches her maximum height. Again, if you need to, go back and look at your graph. She reaches her maximum height at this point right here. You can go and do that second calc and find that first point. It's at 4 seconds. The other way that we know it reached that initial height of the maximum 4 seconds, when we change this to fireproof form, here was that initial phase shift. I was right 4, and because I'm on my cosine, it would be at that maximum value. Let's take it one step further. If I wanted to know the next time I'm going to be at my maximum, well, I've got 4 seconds in here. It only takes me 16 seconds to get all the way around, so 4 plus 16, the next time I would be at my maximum is 20, or again, you can go and look at your calculator. If we go and add 16 again, the next time at my maximum I'm at 36, and so on.